simple, eventually consistent, distributed, structured key value store. Brings together the distributed systems technologies from Dynamo and the data model from Bigtable. Like Dynamo, it's eventually consistent, and like Bigtable, it provides a column family-based data model richer than a typical key value systems. So we'll get to that in a second. So here's the basic layout inside Cassandra. You have keyspaces, which are similar to schemas in a relational database that have column families inside them, which are kind of like a table. And then inside the column family, you have keys, which have rows associated with them, and those rows have columns that have values. So we'll go real quick. So like say your keyspace would be your application data, say, and then your column family may have one column that's the user information, and one that's maybe changes over time. That's an index of what's changing. And then you have your keys along the side. So keys in Cassandra are stored based on what Cassandra calls the partitioner. And the partitioner determines how data is spread across your multi-machine cluster. The usual use of the partitioner is what they call the random partitioner. So keys are stored in a random order. And the order is basically the MD5 hash of the key, but in terms of anything else, it's basically random. So you can't do any kind of ordered querying across keys in a normal use of Cassandra. That's going to split all of your data evenly across your cluster very easily. There are ordered partitioners that will sort the keys in an order you specify, but those are harder to use in terms of keeping your data distributed across your cluster evenly, because it uses that key order to put stuff onto servers. If all of your data is ordered, you're going to have hotspots when you're inserting that data. So the recommendation really is use the random partitioner unless you really, really have to not use it. And you really want to know what you're doing when you don't use it. On the other hand, columns, on the other hand, are sorted in column name order. And the column names, there's a bunch of different types you can have for column names. They can be strings, they can be numbers, they can be time-based UUIDs, which will sort in time order. And that lets you do interesting things with the indices. So if you use a time UUID, you can actually query, give me all the columns inserted between 5 o'clock and 6 o'clock. If your column name is a time-based thing. Or for strings, you can query, give me all of the columns between A and B, and it'll, do a string compare on all the column names and give those back to you for the given key. More about that. And then with the columns, you also have every column has a value that can go along with it. And values can be, values are bytes. And you can also, if you're schemaless, the value can just be a byte string to Cassandra, or you can actually tell Cassandra the types on your values, and that's where you can use some indexing things. If you tell it, that age is going to be an integer, like if someone inserts age, Cassandra can do some indexing on that. You can tell it other things. And we'll get into that. And so I was saying, so basically multi-level dictionary. Got your column family is the the first key into that dictionary. Your key within that column family gives you your row, and your row really looks like a dictionary of column name to value pairs. It's really actually an ordered dictionary inside that column. Those rows have an order to, the columns have an order to them. And the Python tools will return that column to you like it's ordered. So you can use it as a dictionary, or you can actually find it get it in order. If you want to get it. Cassandra is an official Apache project, so you can get it from apache.org. There's also DataStax is a consulting company that's built up around Cassandra. One of the main contributors to it started the company, and they have some Debian packages and some Red Hat packages and some other stuff you can get from them around Cassandra. But you can use their packaging for free. They sell services. How do you run it? So when I talk about development instance here, so basically to install it, there are two configuration files really that you'll need to touch. There's one file that says where to put the data directories, and the other where it's going to store data, and then there's the logging file that specifies how you want Cassandra to log and where you're going to do it. So those are two things you probably want to edit. So start script. If you're using a development instance, we want to say -f says run it in the foreground, so it's going to, by default, it's going to spawn it off into the background and run as a daemon. And Cassandra's designed such that to stop it, you run the kill command on it. There's no stop command, you just kill the process. And it's meant to be fault tolerant to that. Some stuff for when you're using it for development. What I usually do is make a template file out of those two configuration files, and then modify the start script to take those templates, figure out what path it's running at, and stick the data under there. So you can just check all of this into your source control. And when the developer pulls it out of source control, the first time they run that start script, it's going to start up a local instance of Cassandra on their machine with the correct paths for where they are. And it makes it real easy for developers to start up a local instance. So once you've got it running, the first thing you need to do is set up your tables, your key spaces and your column families that you're going to run against. Really the best tool for that right now is the command line interface. You can do it programmatically, but changing key spaces and column families is not usually a good idea. Not usually something you want to do on the fly. Because you want a controlled environment when you do that, because you really want to make sure that stuff propagates to all your nodes. So you want to make sure all your nodes are up before you change something. You don't want some program doing it on the fly and maybe a node's down, and when it comes back up, it has to do some schema migrations and figure stuff out. And you also want to make sure that there's only one schema change going on at a time in your cluster, which is another reason you can do it programmatically, but it's really better to do it from a separate tool, or at least don't stick it in your main program, write a separate program that's going to do it, so you have control over that. And so you're going to connect to your instance, create a key space. There's a thing called placement strategy, which basically tells Cassandra how to store the data across this cluster. The simple strategy just stores data in key order across the nodes based on your replication factor. For a development instance, your replication factor is going to be 1 because you're only running it on your local machine. There's other strategies that will distribute the data across data centers, network aware, and other things like that. There's a lot of stuff you could do with that. And you're going to use your key space and create your column families inside it. So in the figure, we're going to make one column family that the columns are ASCII, and another one where the columns are time UUIDs for how it's going to sort the columns. So then to talk to it from Python, there's a few different ways you can do it. There's the straight thrift client. Cassandra is written using the thrift RPC mechanism. Thrift is another Apache project that basically lets you create configuration files for how a remote procedure call is going to work, and they have generators for 50 different languages for being able to talk to that. You don't really want to use that directly. That's a very low-level interface, and it's pretty ugly to use. And then there's the pycassa client, which is a Python client. It's a higher-level client built on top of that thrift interface. That I'm going to be talking about pycassa today. If you're doing Python, there's a twisted client if you have a twisted application. And if you're using twisted, you will know what that is, and that's the one you want. And then Cassandra also has a new interface called the CQL interface, or the Cassandra query language, which is basically a SQL-like query language that's being built as an API. And so there's a Python DB API 2, which is a Python database interface standard client built on top of that CQL that you can use. The CQL doesn't have all of the features of the thrift interface yet, but it's getting there. I mean, the goal is they're going to have parity. But right now I'm going to talk about pycassa. So basically, this is why you don't want to use the thrift. So this is thrift for connecting and inserting one row with one column, and here's pycassa for inserting one row with one column and connecting. And so it takes away all the thrift junk. So pycassa connect. Pycassa has connection pools. Do all the stuff that connection pools do. Tell it a key space and give it a server list. It's going to do failover between the server list. Create a thread pool, and if you have multiple threads, it's going to hand out connections, one to each thread, so that your connections are balanced across the different servers, so that you're going to get more concurrency. Cassandra single-threaded has pretty good performance. Multi-threaded is where it really shines, because you get a very linear speed speed up as you add more clients. And then as stuff slows down, as you add more servers. Netflix recently did something where they went up to like 1 million clients, and they had basically linear speed up across number of servers for 1 million clients. It's pretty impressive. You can find it on the Netflix tech blog. They have a whole blog post about it. And so once you have your connection pool, you're going to open and connect to a column family. You create a column family object, give it the connection pool, and what column family that you want to connect to. And then, so you want to write, pretty simple interface. You're just going to call insert, give it your key, give it a dictionary that has your column name to value pair inside it, and it's going to get inserted. Read, it's the opposite. Call read, or call get, pass it in your key. You can optionally pass in column names, and it'll only return those columns. You don't give any names, return all the columns. Deleting, the same thing. Give your key, and optionally a list of columns that are going to get deleted. Interface most people probably use more is batching. So, one at a time is always slower than lots at a time. So the batching interface is very simple. You just give it multi-level dictionaries instead of the key in the single-level dictionary. So you give it a multi-level dictionary. That the first level of the dictionary has the keys in it, and then the second level has the column names and the values. And then there's also a streaming batching interface inside pycassa that you can give an optional queue size to. And if you give it the queue size, so in this case, every 10 operations, it's going to send that off to the server. So you can make one of these, pass it into some process that's just running through data, calling insert, insert, insert. This is going to build them up and send them. Or if you don't specify a queue size, it's going to have an infinite queue size, and it's only going to do it when you call send. And you can always call send early, even if you give it the queue size. And it's the same insert. And you can have inserts and removes in one batch. You can have both inserts and removes. If you get it off the column family, this is all batching within one column family. But you can also do multi-column family batches, where you create this mutator object, and then you specify for every insert or remove, you just give it a column family object that says which column family that's going to operate on. And when it sends it off to the server, that's going to be sent off to the server in one request across those column families. That will succeed or fail, across those column families. So this is good for, if you're inserting a data value and something in an index about that value, data value, you can put those together into a batch, send them off together, and so your data and your index update are going to happen at the same time.
Is there a way to send a batch where you want to load like a file of data to insert?
This doesn't have one. It's pretty easy to loop across your data and do it, but this doesn't have an interface for that. Now, there are other interfaces outside of Python that have bulk loading interfaces through Java tools. Cassandra's written in Java. So a lot of those kinds of things are Java tools for doing bulk loading of data. So they're out there. And then so the UUID here. So we said we're going to do a time-based UUID in Python. For that, you use a UUID1, because that's going to give you your timestamp unique identifier. And you say you want .bytes to get it into the bytes format to insert. Or I'll talk later about how you can specify to pycassa or in Cassandra itself that you're going to be inserting a UUID for that. So you don't have to say .bytes. Pycassa will say, hey, this thing wants a UUID, so it's going to automatically take that object and convert it to bytes. And then batch reading, you use multi-get, and you give it a list of keys, optional list of column names, also pretty simple. And so I'm talking about the column slicing. So this is where you can use the fact that columns are typed to get data between two things. From Jane you can get all columns starting at email and finishing at state, and it'll give you everything that's sorted in between that. Or you can also specify counts, and you can ask for things to be reversed. So this will give you the last two columns from Bill's row. All right, and then you can specify types. So this is your schema optional. So, and you have actually through pycassa, you have two ways to do this. You can, if you've set the schema information up in the database itself, then you don't have to do this here. if you haven't, pycassa when it connects will read that information and automatically set this stuff up. But if you haven't set it in the database, but you want to put a schema on top of it for your client, you can tell pycassa, the age column is going to be an integer, the height column is going to be a float, and then when you do your insert, you can just use, the integer 32 or the floating point value 6.1, and it's going to convert that into bytes and insert it as bytes into the database. And then when you read back out, it'll give it to you back out, and it'll take those bytes and convert them back into a number or a float. And there's a bunch of different types that it supports, and it's very easy to add new types to it. And then with that typing functionality, it has a concept that's similar to, kind of like an object relational model with no relation, and it's an object model, where you can specify objects, and you can tell it what the key for that object is going to be, what type, and you can specify attributes and what types they are, and it's going to take these attributes and call them column names and this key for looking it up, and then you create a column family map object from the object you create with the type information in it, what connection pool you want, and then what column family you're going to connect to. And then you can do things like this where you create a user object, set its keys, set the attributes in it with their different types, or even a date-time object in Python, and then insert it, and pycassa will take all that stuff and convert it down to the binary formats of those things and insert them into the database. And then when you read back, read with that key, and it's going to return you one of those user objects that already has all the attributes populated with the data from that row. And you can also do multi-gets with multiple keys, and then removing, you pass in a user object and delete it. So then indexing. So indexing is very important when you're using a key value system like this, because you only have one way to get at your data really, which is by the key. And so in Cassandra, there's really two ways you can do it. There are built-in indices that you can specify in your schema. Hey, Cassandra, I want you to index this column. And first, I'm just going to touch on anything. There's a bunch of links in here for good articles on indexing and different ways of doing it, and other. It's a very important thing to look at. So the native indices, they're really easy to use. Like I said, you say, hey, Cassandra, I want you to index the age column. I want you to index the state column. And then you can actually do queries. You say, give me everybody from Illinois, or give me everybody who's 20. And you can actually do filtering queries as long as one column is an equality in that query. You can actually do greater than, less than queries, and there's a couple other operations you use. You can say, tell me everyone in Illinois who's over than 20, and you can actually do that query with the built-in indexes. But they're not recommended for high cardinality values, because Cassandra under the scenes is basically building a hidden column family for that index that's turning that index into a key value pair query under the scenes. So if you don't want to if you blow out the number of columns that are, number of unique values that are being indexed, it's going to make your query slower, because now it's got to look at that index with the huge number of things, a billion things in the row. I think Cassandra has a maximum row size of 2 billion. So you can get a lot of columns in there. But okay. And then also, if you use the built-in indexes, it makes your writes slower, because for every write, the server has to do a read before write to check if it has to remove something from the index when it inserts the new thing into the index. Whereas a normal write just purely goes to a commit log and returns, so it doesn't have to do any kind of reading for a normal write.
So it's not recommended for high cardinality values.
Where high cardinality is billions. If hundreds of thousands, still okay. So just depends on what you're doing.
Like a customer ID.
Yeah, exactly. So depending how many customers you have, maybe okay to index it. But if you're Facebook, probably not okay to index it.
So that customer ID is like somewhat of an intelligent number, or could you index parts of it?
Not with the built-in, unless you put those parts in different columns.
So the customer ID can be the key.
Yeah. Customer ID can be the key. Yeah, and if your customer ID is the key, then you don't need to index it, right?
Okay.
This is just for things that aren't the key.
Okay.
everyone whose state is Illinois, and I'm saying you can do filtering, so whose age is greater than 20, and then you just say column family, get index slices from this clause, and it's going to return you key data pairs for everybody that's in that. You can loop through that and do whatever you want. And it actually uses a Python generator behind the scenes and does internal batching, so it does paging to the server. It has a default page size of I think 1,000 columns, or you can change it, or you can also specify a maximum. So specifying this count here says give me a maximum of 20 rows. All right, and then you can also, as I said, roll your own indices. Use that multiple column family batching stuff to do your own indices. Now when you do that, you have to deal with the read before write problem yourself. But if you're only inserting new data, you don't have to take that penalty. If you know it's new, you don't have to do a read. You can just write twice, and it's going to be fast. And the other thing you do when you roll it yourself is you can make your index into a denormalized query instead of just an index. So you pull that index, and you actually get all your values you want, because you stick the data inside the result there. And then you don't have to read the index and then read the row. And then there are other techniques. So you can if you roll your own, you can do something kind of like when you want to, where you index on this field and not this other field. It has the concept of composite columns, where basically you can say this column is these three things. Maybe it's an integer and a string and whatever, and that can be one column name. And you can actually use the built-in indexes with that and search on those individual fields in order. So if you use the built-in index with the composite column, you can say, this guy's a number and a string, and so you can say, give me all of the columns where the number is 20. And it'll do that, or give me all the columns where the number is 20 and the string is this, or whatever you want to do. So some lessons learned that I've had with using Cassandra over the last year and a half. Use indexes. Don't iterate over the keys in your database, because that's just going to be slow. We had some data that we thought, this isn't going to be so big. We'll just run through it and do it. And unless you're doing a map reduce operation across it, it's make an index. The other thing is, if you have a new query, you're probably going to want to think of a new column family to put your data in, so that you can access that by key. Denormalize everything. Don't be afraid to write your data twice. You do have that batching interface where you can group a bunch of things to different column families together. Say, write this to the database, and they'll be written together. And you want to do that. Any other questions? Comments?
So, is pycassa aware of, the connect string seems to be very simple.
Yep.
But is it aware of the cluster and?
So the connection pool, there's actually options on it. So when it connects, there's options to tell pycassa to, after you connect, query the database to get the server list. So you can have pycassa go ask the database what all the servers are, so that it can round robin across them, or you can have it just only use the servers I tell you. I think the built-in querying stuff, if you do go into like a multi-data center model, I don't think pycassa yet understands the concept of, I want to ask the database for the servers in my current data center. So if you do use that and you have multi-data centers, it's going to start sending stuff across the world or whatever. But there are functionalities for querying Cassandra and asking, what's your server list? And the other thing, in that question is very simple. When it connects, it queries, when you connect to a column family, it actually queries the column family for its schema, if one has been set. So it can do the automatic type conversion and stuff like that based on column names.
The Netflix folks had done some work on figuring out what key might be there, and then therefore, within the connection pool, being able to use the correct and all those things. So pycassa isn't there.
I don't think pycassa does that. I'm not sure if they do any of that under the hood. Netflix can do it easily, because Cassandra is written in Java, and Netflix client that does that is written in Java. And so it just uses the Java jar file from Cassandra to ask the Cassandra library itself, where does this key go? so that they're not re-implementing those algorithms. They're using the library from Cassandra to do that, so they don't have to worry about, oh, Cassandra decides to change that algorithm, now our stuff's broken. Or, well, just going to the wrong server first, so they're, you thought you didn't have an extra hop in asking for data, but now you do. And the one thing about Cassandra is really, all the nodes are equal, so so you're going to get at most one extra hop out of a query when you ask for something. Because the node you talk to, you may have to talk to somebody else.
And I didn't see anything like, the replication factor getting specified in the API, or did I miss it?
True. So that's true. So you can specify it. Pycassa, I don't remember what it defaults to. I think it defaults to quorum. It may default to 1. But so when that is another parameter that all of your queries to Cassandra, you can specify how many servers do you want to respond to this query before you consider the answer valid. So if you said your replication factor is 3, you can tell it, I just want to talk to one node, and the first node that tells me an answer, I'm going to use that as my answer. Or you can tell it, I want all of the nodes to respond, and I'm going to use the conflict resolved answer as which one's the newest answer. So if one server was down when the value got written, when you ask for it, that guy may have stale data. So if you use 1 and you talk to him, you're going to get stale data. But if you say everybody, you're going to get the conflict resolution that's going to give you back the right answer. And also the concept of quorum, where it's n over 2 plus 1 nodes respond. So if you read and write with quorum, you're going to have consistent data for successful query, successful reads and successful writes at quorum. Whether it be consistent or they'll fail until there aren't enough servers up to satisfy that.
So what was the main motivation behind the Python there, for you specifically?
We already had a lot of Python code.
What is your use case then?
We're using it for an operational data store. And we're keeping history tracking in it as well. So we store current value of data, and we store changes to data for the past 90 days. And we use the time to live features in Cassandra. So whenever we insert something into our historical table, we give it a 90-day time to live, and Cassandra will automatically throw away the old data as that expires.
How was the query performance for an ODS? You would probably have to iterate through keys.
Not really. Most of our stuff where we're inserting something, for the most part, we're inserting everything by key. For the most part, we know the key, and we have a few different indices for, we keep indices of what data points are set for what key and stuff like that, so we can query that. We actually started this before Cassandra had the built-in indices, so we're not using any of those because they didn't exist when we started. But use the batch interface to write everything out. Do them ourselves.
Did you do any comparisons with the MongoDB?
It didn't fit our use case. And we looked at it. We looked at most stuff.
Like anything specific?
The multi-data center stuff is not really there at all. Yeah, the biggest thing with Cassandra was their multi-data center aware replication and querying. So you can insert something into Cassandra and say, insert it consistently into my data center and asynchronously into the other one. Or you can say, insert this consistently into every data center that I'm connected to. Or there's all kinds of different query stuff for depending on how consistent you want your data and how fast you want your query to be. What you can do. That's one of the biggest features. And then the column-based model where every key can have multiple columns associated with it also works nicely. For a lot of the other key value systems, you have your key and your value. And if you want a different value with that key, you make a new table.
So do you put nodes in different locations, or
yep.
like
different locations?
And then you just
so when you create your key space and your column families, right? You had that placement strategy. So one of the placement strategies is basically a network-aware placement strategy. And there's actually a bunch of different ones. There's one where you give it a configuration file that has like a list of IP addresses, and then you tell it So and actually is aware of racks as well. So if you want to say this rack versus that rack within a data center, you tell it what rack something's in, what data center something in, and Cassandra will use the rack awareness to do closeness. So if I'm asking for something with, consistency level of 3 or querying, and I say I want it from 2 nodes, it's going to look, okay, which node is in my same rack, and ask him for the data. And then it also has the data center awareness stuff where you can set your replication factor actually distinct between data centers. So you can say in data center A, I want it on 2 nodes. In data center B, I want it on 3 nodes. In data center C, I want it on 1 node, whatever you want to do. And basically, when you set those up, every data center kind of acts as its own ring in the Cassandra parlance of data placement. And then so you can just set that up like that, and then it has, like I said, the querying ability. When you query stuff, you can say, give me consistent level 1 from the current data center. So just give me it as fast as you can, or you can actually say, give me a consistency level of all from every data center. So it's going to make sure you have the newest value from every data center out there. It's just going to take a long time. And if you look at and although it's still pretty fast. And like I said, Netflix actually has a lot of benchmarks that they published about using multiple AWS regions with Cassandra clusters that span regions and different consistency levels and querying types across those different data centers. Some fairly extensive results they posted online. And they also posted how much it cost them to do the benchmarking if you want to repeat it yourself.
So I was reading about some, like I'm new to the whole Cassandra world. I was reading about some distributed caching article, and I came across Cassandra being compared to Memcache, for instance.
Yeah.
And it recommended that for high read situation, Cassandra is a good database. But I don't know how that applies. Can you, all the
basically, because Cassandra's, in essence, a key value system, lookups are very fast.
But it's
depending what caching you have on, a lookup can take, may only be 1 disk seek to get the data off disk if it's on disk. It has different caching levels available for storing, on disk data. Cassandra has caches. You can set up caches within Cassandra so that data is kept in memory and stuff like that, so that you may not need a memcache on top of Cassandra because Cassandra can serve the data fast enough, that you don't need to maintain 2 systems.
Okay. Because I was assuming that it's true for any kind of column-based storage that underlying seeds are going to be that way. So is there any special caching mechanism?
Well, you also get the redundancy and the distributed and the et cetera, right? Where in the case of if you with Memcache, I don't know how if Memcache has distributed stuff yet besides sharding. Where the data is distributed, so you can query the 3 servers or whatever, and get you get all the Cassandra stuff, and it may be just as fast as your Memcache.
I think with Memcache, I'm not aware of any product or open source solution that does replication, which is usually the first big question that comes up.
Yeah.
Because I visualize Memcache as something in memory. It's scattered across.
Well, that's the thing is, already storing your data in Cassandra because Cassandra fits your use case, you don't necessarily also need a memcache.
No, I think you
That's
answered
a lot of the articles.
You answered my question when you said
yeah.
Cassandra can be in memory.
Right, exactly. I mean, it could if you have enough extra memory on the system, Cassandra's going to be in memory.
I was thinking of Cassandra as something of persistent storage versus memcache, something in memory.
The other nice thing about Cassandra, so Cassandra, when it writes data to disk, Cassandra only ever writes files to disk once. So once those are read, like your OS is going to start caching those files, and we've actually found that's a very big performance gain. If your data files on disk fit in the OS disk cache, Cassandra doesn't go changing those, so they won't really get evicted or have any issues with that. So they get into the OS disk cache, and then your queries are basically out of memory.
So to be fair, Cassandra is a memcache, if I can call it a competitor.
Kind of.
It is not. To your question, any database will cache some amount of data. And that's what Cassandra is doing too.
Yeah.
So it can be entirely in memory. So maybe I'm just looking
Yeah,
for a reason why that was
it just
comparing
depends.
memcache and Cassandra.
It just depends.
Or caching.
Any database can be.
Correct.
Yeah.
But given the large number of nodes, it is potentially possible that you are able to.
Yeah, that's the biggest thing is with Cassandra. You can spread it out across a bunch of nodes. Each node maybe its portion of the database fits in memory.
Coming back to the pycassa implementation, the batch interface, is it a huge performance gain to go batching, or does it give you?
Batching is a huge performance gain no matter what. No, it doesn't give you transactionality, but it does give you any operation on a single row, a single key. So all of the column changes for a single key are committed to the database atomically.
Right.
It doesn't give you transactions, but it does give you certain atomicity, guarantees for success and failure. So if it fails, everything failed. If it succeeded, everything succeeded, and the changes to a given row are going to be atomic. Now across rows, your changes aren't atomic, but your batch maybe will succeed or fail together. But if you have something reading those rows at the same time, row 1 row 1's new value may be returned to something that batch queried 1 and 2, and maybe row 1's new value and row 2's old value because the batch hasn't finished updating 1 and 2. But across that read, all of the data inside row 1 that changed will be consistent for that read.
So with pycassa, the way Cassandra does errors is a little peculiar to put in mind. What does pycassa do to handle?
You can for some of the stuff you can set up retries on different so with the server list, you can have it do automatic failover if something times out, or not depending. Cassandra writes to a Cassandra database are idempotent. So if it has get a timestamp assigned to them, and as long as you're writing with that same timestamp, a new write with a higher timestamp, even if you write the old value with the lower timestamp, the higher timestamp's going to win. So you can keep replaying that write until it succeeds, and it's not going to hurt anything. And you can tell, and pycassa by default will do that. If it gets like a timeout exception or an unavailable exception that says, I would either, a node was down or a node was not responding or whatever, it can keep trying.
Does a pycassa API, does it provide a capability to provide that timestamp?
Yeah.
It does.
Yes, and you can also specify the timestamp. You don't have to. By default, it's going to use current system time in microseconds. But you can also specify it, and you can also tell it you want it to return the timestamp. And then the values, when it gives you the values back, it'll give you back a tuple that has the value and the timestamp for that value. So if you care about those timestamps, you can get at them. And like any other system accessing Cassandra, you want to make sure everybody writing and reading from the database has the same system time. So make sure your network time protocol is kept in sync. It's true of most distributed systems.
So
a selling point for their Brisk Hadoop Cassandra backend is you can do your analytics Hadoop stuff on the same cluster you're doing your, OLTP, whatever data inserting, querying stuff. And it's one cluster. You don't have to keep exporting your data to something else to do your Hadoop jobs. So I've never used it, so I don't know if that marketing is true or not. But that's their marketing piece on that.
Yeah.
And then and if you do want to use Cassandra, I would definitely check out Netflix's tech blog. They talk about their use of Cassandra a lot. And they've actually open sourced and released a lot of their management tools and infrastructure tools around using Cassandra. Their client libraries that they've developed for using Cassandra from Java. They actually set some interesting like backup and recovery tools that they've created for backing up Cassandra databases that are running in Amazon, spitting incremental backups to Amazon